So as of 0800 today, our position, the range from here to Turtle Bay was 270 nautical miles. We've been averaging speed over the ground the last 20 hours, about 7 knots of speed. We've come 140, 139 nautical miles so far as of 0800 this morning. That's a 20-hour run time because we started yesterday at noon or 1200 hours. So we run for 20 hours. We've come 140 miles at 7 knots. And I just double checked, to make sure that my speed calculation was correct. I have a speedometer, but I did take 20 hours of run time divided into the 140 nautical miles, and that confirmed that my speedo is correct. It also came out to 7 knots, so it was just a double check.
So you got over that time frame, you were able to confirm the average of 7 knots.
Confirm the average of 7 knots of speed over the ground. So, looking at a fuel gauge on my boat, and it looks like that in 20 hours we have burned 36 gallons. We started off with 100 gallons of diesel fuel in our tank. It looks like we have about 64 gallons left. So when I divide 20 hours into the 36 gallons that we burned, that gives me a burn rate of 1.8 gallons per hour. We were running the engine at 3,000 RPM, which is a pretty high speed. Maximum cruising RPM for this engine is 3,200 RPM. So we're just under our maximum cruising speed.
So at that RPM, we're using the most amount of fuel we can burn per hour.
You would use the most amount of fuel you burn per hour. In theory, you also are going faster, but it's a trade-off. How much faster are you going at that high RPM? So this is probably the slight mistake I made in my initial decision. I started off and left Cabo San Lucas at 3,000 RPM. I should have been more conservative and started at 2,800 RPM because we burn less fuel and we only go about half a knot slower. So we have, as I said, 100 gallons of fuel in our main tank, but we have 4 jerry cans. You want to show them the picture there? 12 jerry cans. They're 5-gallon cans each. So that's another 20 gallons of fuel there as a reserve. So I got a total of 120 gallons of fuel. I calculated that with 140 miles we've already gone and the 36 gallons of fuel I estimate we burned, that means we're getting 4 miles per gallon.
So real quick, simple math on that. If you take that 36 and you multiply 4 times the 30, that's 120. And then 4 times the 6 is 24. So that you add those together, you get to 144. So that's a pretty quick calculation way.
Exactly. So if we have averaged 4 miles per gallon the last 20 hours, and I started off with 120 gallons of fuel, then in theory I've got the potential to go 480 miles. My total range is 480 miles before I run out of fuel. So the calculation to Turtle Bay was 410 miles. So we should have a 70-mile reserve. Alright? So we've got 20 gallons on the back of the boat, 64 gallons in the main tank. That's a total of 84 gallons. If I'm burning 1.8 gallons per hour, that means I can run this engine for another 46 hours. However, that 1.8 gallons per hour was at 3,000 RPM. We've decided to be a little more conservative, a little more economical, and we've reduced our engine RPM to 2,800 RPM. Probably getting about a 1.5 gallon per hour burn rate, which will give me far more than 46 hours. But we are in good shape. We should get to Turtle Bay with enough fuel left to go another 70 miles, and I feel comfortable with that safety factor. Especially if we get a chance to put up our sail and get some drive from this wind to help the motor. That'll even improve our economy better.
One of the interesting comparison is Tim and I are both about the same age here, and back in the 70s we started to learn how to drive cars, probably about 73 or 4, right?
Yep.
And a little bit later on in the 70s there was an oil embargo and a bit of an oil crunch, gasoline crunch, and so the government, the United States, turned the speed limits back on the highways to 55 miles an hour as opposed to 70 miles an hour, because it would mean people would be more fuel efficient and fuel would go further and more efficiency. So we're doing the same thing here with the boat and trying to gauge the distance we need to go with the fuel we have to get there. You can do the same thing in your car. If you're running a little bit low on fuel and you need to get to Chicago and you're 20 miles out, you don't know you have enough, driving at 80 miles an hour, you'll burn it up a lot faster than you go at 50 miles an hour. So it's the same kind of comparison.